Alright guys, welcome back. We're going to be solving questions 3 from the chapter 7 of Beer and Johnston textbook Engineering Mechanics. And in this one, we need to determine the internal forces at point J when our alpha here is 90 degrees. So first of all, for finding the reactions at J, we can do a section at J and either go with this part or the bottom part. But before moving to that, we need to find all the reactions that we have in this question. So we're going to start with the free body diagram of the entire system or entire frame. So we have a pin at point B, which means we have Bx and By. We have the force D, our alpha is basically 90 degrees. So this is our D, 780 Newton, since our alpha is 90 degrees. So ignore this one. And we also have the tension in the cable at point A. We can call it T, or let's just call it A. It's easier. And we are in equilibrium. We can do sum of all forces equals 0, and same for the moment. So for finding the moment about point A, we basically can cancel out the moment of A. We can cancel out the moment of Bx, and also 780 is going to pass through A. And we're left up with the moment of By times 300 is equal to 0, which means our By is 0. So we found the first unknown. Now we can do sum of all forces in y direction. Let's consider this our positive y. So basically we have the y component of A, which is what we have in here. And for doing that, we need to figure out some of the angles. So we can call this angle alpha, which is this angle alpha. So if we look at this right triangle that we have in here, we have 300 for this side. The other side is 480 plus 240, which is 720. So we can find the hypotenuse based on Pythagorean theorem. 300 squared plus 720 squared. That's going to give us 780. So the hypotenuse is 780. Now we can find the sine and cosine pretty easy. So Fy would be a cosine of alpha. So a cosine of alpha would be 720 divided by 780. And we have minus 780 is equals 0. Our A would be, so 780 squared divided by 720. It's going to be 845 newtons. We did not get any negative answer. That shows that the direction for A was correct. And now we can do sum of all forces in x equals 0, which is going to give us this time A sine of alpha, or 300 over 780 plus bx is equal to 0. So our bx would be minus, let's calculate this, 845 times 300 divided by 780. So minus 325, and the negative sign in here shows that our bx was actually to the left. So our assumption for bx was incorrect. We found all the reactions. We can move on to the free body diagram of this part, bj. So we're going to draw the free body diagram of bj. So we figured that we only have bx to the left, which was 325 Newton from the previous part, and we're going to have different reactions at point J. Can call one F, the other one V, and we're going to consider one moment as well. And we have to find all these reactions, but we're going to take a different X and Y for this one because it will be easier for us to proceed with fx with f or with finding f and v. So let's call this our y prime and this one x prime. So now we have to break down the 325 into two forces, one this and the other one this. And for that, we need this angle, which is the angle of BX, and what we have in here, which is also pretty easy to find if we consider this right triangle right here. So we have this side again, 720. The bottom is also, let's clean this, 302. So basically we have same as what we had in here. The hypotenuse would be 780. So this will be our alpha. Let's just call it beta, differentiate with the previous one. And here is beta. So here this angle is beta. So let's do sum of all forces in x prime first. So what we're gonna have is basically F minus 325 cosine of beta. We're talking about this one, and cosine of beta in here would be 300 divided by hypotenuse. 300 divided by 780 is equal to 0. Our F would be 325 times 300 divided by 780, which is going to be 125 newtons. And the angle that it's going to make, if we want to report the angle with our x or this one, we just have to find beta. So let's figure out beta. Beta would be the tangent inverse of what we have opposite over the adjacent 720 divided by 300. So our beta will be tangent inverse of 720 divided by 300, which is going to be 67.38. So the angle here would be 67.38. We found the first reaction. We're going to do sum of all forces in y prime. For beta, we're going to have the opposite over 780. So 720 divided by 780 minus v is equal to 0. Our v would be 325 times 720 divided by 780. That's going to give us 300 newtons. And the v that we have in here, if we want to show this angle here, or what we have in here, so let's show that angle. It's going to be 90 minus beta, or 90 minus 67.38. It's going to be 22.62 degrees. So for finding the moment about point B, we basically have the moment of Bx and the moment of M. We consider our M counterclockwise, so we have positive plus. The moment of B is also counterclockwise, so that one's positive too. So the distance would be the vertical distance to the line of action, which is what we had in here, or what we have from here to here, 480. So the force Bx, as we found, was 325. So 325 times the distance, 480 divided by 1000 in order to get it in meter equals 0. That shows our moment is counterclockwise. So minus 325 times 480 divided by 1000 minus 156 Newton meter. The negative sign shows that the moment is actually clockwise. So yeah, that's the final answer for this question. All the reactions, hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.